Today we are going to discuss Unit 2, the fundamental of analysis and algorithm efficiency. So initially we have to go through the analysis framework. So in analysis of algorithm we have a term called efficiency. So in efficiency in our algorithm it is basically in two categories. One is space complexity, another one is time complexity. So based on the space and time complexity, our algorithm's analysis will work. So in analysis framework we have several categories of steps. So initially we have measuring an input size. So based on the input size our time and space complexity will may differ. And then we have unit for measuring running time. So we can calculate the running time of the units to analyze the framework. Then order of growth, based on the order growth we can find the complexity. Then we have worst, best and average case efficiencies. If the algorithm may work in different ways with the given input are same, then we can find out the worst, best, average case analysis. Then we have recapitulation of the analysis framework. So the first one, size of the input. So basically whichever the algorithm we are going to work, the size of the input is important. So here the efficiency of the algorithm is evaluated based on the input size. For example, if you calculate the word count of an algorithm, then the number of words which is occurred in the particular sequence of sentence will carry the size of the input. In case if we have an alphabet count, then for example if the word Malayalam is available, we may able to identify M-A-L-A-M-A-M like Malayalam. So based on the individual letter count, our alphabet count algorithm will works. For example, if the word is size, S-I-Z-E, so we have only 4 digits of alphabet count. If you go with more than 4 digits, it may give based on the number of size of the character or size of the string or the length of the string, your alphabet count or word count algorithm may execute. In some cases, in sorting and searching algorithms, we may have a same size of input, but your algorithm will may work differently. It will produce the outputs differently or same with different running time. The next one is running time, that is units of measuring a running time. So the complexity of the algorithm is basically depends on the measuring unit, like times per second, minutes. Likewise your running time will be calculated. So here for example, if a unit is measured in terms of seconds, then the efficiency will be calculated in terms of seconds. If your algorithm's running time will be calculated or measured in terms of minutes, then the efficiency will be calculated in terms of minutes. So mostly the algorithm's running time is directly depend on speed of your computer hardware, because based on the performance of your computer hardware we can able to identify the running time of an algorithm. If you compare an algorithm, same algorithm which is running in i3 machine and i7 machine, you can easily compare the time seconds, because your i3 will work slow or run slow when compared with your i7 processors. And the order of growth. So the efficiency of an algorithm is evaluated based on the growth of order which is performing by the size of the input. For example, if the system is executed with the same input size and it is compared with the system is executed the input size doubled or tripled, so that is how the order of growth will be ensured. If you take an example of